In the decades since the Apollo program achieved the unimaginable, landing humans on the moon and returning them safely to Earth, space exploration has transformed from a competition to a collaboration, from a race to a relay. The stars that once seemed so far out of reach are once again within our grasp. And now, in the 21st century, NASA has set its sights on something truly historic, not just returning to the moon, but establishing humanity's first sustainable presence beyond Earth. This is the Artemis program, a mission that carries not just scientific objectives, but cultural and generational significance. Named after the Greek goddess Artemis, twin sister of Apollo, this program is deliberately symbolic. While Apollo represented a singular, heroic moment of the past, white, male, and nationalistic, Artemis signals a new era, inclusive, diverse, global. The first woman, the first person of color, and international astronauts will soon walk on the moon. And they won't just visit, they will stay, work, build, and prepare for the next giant leap, the journey to Mars. But to understand the full gravity of the Artemis mission, we need to understand how far we've come and how much further we aim to go. After the Apollo era concluded in 1972, NASA turned its focus to orbital missions, the Space Shuttle program, and long-term habitation aboard the International Space Station. These were vital stepping stones, but the dream of deep space exploration remained dormant for decades. Political cycles, budget constraints, and shifting priorities kept crewed lunar missions in limbo. Presidents made speeches about Mars, concepts were drawn for lunar bases, but nothing concrete moved forward until recently. As technology evolved and private companies began demonstrating the ability to build reusable rockets and perform precision landings, NASA saw a window of opportunity to not only reignite its lunar ambitions, but to do so with a new model, one built on partnerships, commercial innovation, and long-term vision. Thus, Artemis was born. Officially announced in 2017, Artemis aims to return humans to the moon by the mid-2020s and establish a sustained human presence by the 2030s. It's not just a NASA mission, it's a collaborative framework involving multiple US companies and international space agencies working together toward a common goal. The Artemis program is built on a tiered mission structure, Artemis I, II, and III, being the foundational flights, each increasing in complexity and ambition. Artemis I, launched in November 2022, was a landmark event. It marked the first integrated test of NASA's powerful new Space Launch System, or SLS, and the Orion spacecraft, which will carry astronauts into deep space. SLS is currently the most powerful rocket in the world, standing at 322 feet tall and capable of producing 8.8 million pounds of thrust, more than the Saturn V that powered Apollo. It's built using a combination of new and legacy technologies, including advanced avionics, composite materials, and engines originally developed for the shuttle. Atop the rocket sat the Orion capsule, a state-of-the-art spacecraft capable of supporting up to 4 astronauts on missions lasting several weeks. With no crew on board, Artemis I served as a critical systems check. Over the course of 25 days, Orion traveled 1.4 million miles, performed a distant retrograde orbit around the Moon, and captured breathtaking high-resolution images of the lunar surface and Earthrise, reminding the world of the raw beauty of space. The mission proved the viability of the spacecraft's life support systems, navigation software, and heat shield, a crucial element for re-entry speeds exceeding 24,000 miles per hour. The success of Artemis I paved the way for Artemis II, which will carry 4 astronauts on a 10-day mission around the Moon. Scheduled tentatively for 2025, this will be the first time humans have ventured beyond low Earth orbit in over half a century. The crew will include astronauts from NASA and the Canadian Space Agency, with a deliberate focus on representing the diversity of the modern world. They won't land on the Moon, that comes next, but they will test every human system aboard Orion, from piloting procedures and communications to psychological and physiological stress responses. The Artemis II mission is about trust, demonstrating that NASA's spacecraft and its astronauts are ready to safely traverse deep space. Once validated, the next step is monumental. Artemis III, the first human landing on the Moon since 1972. But Artemis III is where the vision really diverges from Apollo. Instead of touching down near the moon's equator like before, Artemis III aims to land at the lunar South Pole, a region shrouded in mystery and promise. Unlike the sun-baked plains of the Apollo sites, the South Pole features permanently shadowed craters that may hold water ice, an invaluable resource for sustaining human life and fueling future missions. Extracting and using this ice could be the key to building a livable lunar outpost. But landing in this region poses new challenges. The terrain is rugged, the lighting conditions are extreme, and the temperature differentials are immense. That's where NASA's new human landing system comes in. Developed in partnership with SpaceX, the company's modified Starship lander will serve as a lunar taxi, transporting astronauts from Orion, which remains in lunar orbit, down to the moon's surface. Starship will be launched and refueled in Earth orbit using a series of tanker flights, a feat that's never been attempted at this scale before. If successful, it will revolutionize how we move cargo and crew beyond Earth's gravitational well. Meanwhile, orbiting above the moon, NASA and its international partners are developing the Lunar Gateway, a small space station that will act as a command center, science lab, and docking hub. Unlike the International Space Station, which orbits Earth every 90 minutes, the Gateway will follow a highly elliptical orbit around the moon, allowing it to reach both the near and far sides of the lunar surface. It will host rotating crews, support robotic missions, and serve as a test bed for deep space technologies like autonomous systems, radiation shielding, and long-distance communication. Modules are being contributed by Europe, Japan, and Canada, with their respective space agencies supplying everything from life support to robotic arms. Gateway represents more than a platform, it's the keystone of the Artemis architecture, enabling mission flexibility and international scientific exchange on a level never before seen in lunar exploration. The Artemis program is also deeply entwined with Earth-based research and commercial development. NASA is investing in next-generation spacesuits designed for flexibility, mobility, and safety in the moon's harsh environment. Companies like Axiom Space and Collins Aerospace are competing to develop these suits, pushing innovation through commercial competition. In parallel, teams are working on pressurized rovers, autonomous surface robots, and inflatable habitats capable of being deployed and expanded on the lunar surface. Every one of these technologies is a stepping stone, not just for the moon, but for Mars. NASA is treating the Artemis program as a proving ground where every success and setback contributes directly to the development of interplanetary systems. How do you store food for 6 months without resupply? How does the human body respond to low-gravity environments long-term? How do we generate power during the 2-week-long lunar night? These questions are being answered right now, in laboratories, in simulators, and on the testbeds of Artemis. And yet, perhaps the most powerful aspect of Artemis is not the technology, but the vision. Unlike Apollo, which was driven by urgency and rivalry, Artemis is driven by legacy and hope. It is a mission to unite people, inspire the young, and remind a restless planet that progress is possible when we work together. The Artemis Accords, an international agreement signed by over 30 nations, sets out peaceful principles for lunar exploration, affirming commitments to transparency, resource sharing, and mutual benefit. For the first time in human history, multiple nations are preparing to work side by side on the moon, sharing data, conducting joint missions, and establishing cooperative infrastructure. Artemis is not just an American mission, it is a global mission open to the world. As we stand on the edge of this new era, the moon once again fills our skies with promise. Artemis is the bridge between what was and what will be. It is where generations meet, where the lessons of Apollo are passed on to a future built on inclusion, sustainability, and discovery. The countdown is not just for a rocket, it's for a new age, an age where humanity takes its first enduring steps beyond Earth, not alone, but together. An age where space is not a battleground, but a shared frontier. And as the Artemis rockets prepare to rise, so too does our shared destiny, to explore, to learn, to endure. The dream is no longer distant, the dream is rekindled, and its flame will light the path for all who dare to follow.
As the Artemis program moves from proving flights to actual lunar landings, its goals stretch far beyond symbolic footsteps on the moon's surface. Unlike the brief stays of Apollo, Artemis aims to plant the seeds of permanence, a long-term sustainable human presence on the moon. This means not just surviving on the lunar surface but thriving there. It's a bold ambition that requires mastering power generation, habitat construction, mobility, life support, and resource extraction in one of the most extreme environments imaginable. And all of it serves a larger purpose: to lay the groundwork for humanity's next great adventure, the journey to Mars. At the heart of this next phase lies the proposed Artemis Base Camp, envisioned for the moon's south pole. This region, far from the equator where Apollo astronauts once walked, offers unique advantages. Deep within its shadowed craters may lie vast deposits of frozen water, essential for drinking, oxygen production, and even rocket fuel. Nearby plateaus receive nearly constant sunlight, ideal for solar power. Base Camp would begin as a collection of pre-delivered modules, small surface habitats, mobile power units, and unpressurized rovers. Crews would initially stay for short missions of a few days, but gradually extend their time, learning how to live and work in the low-gravity lunar environment for weeks or even months at a time. Power is one of the most critical challenges. While solar panels will play a central role, the 2-week-long lunar night in many regions demands a stable backup. That's where nuclear fission comes in. NASA's Kilo Power project is developing compact nuclear reactors capable of running continuously, unaffected by light or shadow. These systems will supply electricity for life support, communication, and scientific instruments. In addition, energy storage systems, advanced batteries, and possibly regenerative fuel cells are being designed to handle demand during emergencies or peak usage. Getting around on the moon is another key concern. Crews will use unpressurized lunar terrain vehicles, essentially space-age trucks, for short surface excursions. Later missions will introduce pressurized rovers that allow astronauts to travel long distances without donning bulky suits, making multi-day science expeditions possible. Eventually, robotic systems may scout landing sites, set up infrastructure, and perform maintenance, paving the way for more complex operations and larger crews. These vehicles won't just support exploration, they'll act as mobile laboratories, construction platforms, and rescue transports in emergencies. Sustainability on the moon also hinges on in-situ resource utilization, or ISRU, the idea of using local materials instead of relying on Earth. Regolith, the powdery lunar soil, can be processed to extract oxygen. Water ice can be turned into fuel. Even the dust itself might become building material through three-dimensional printing and sintering techniques. NASA is already funding prototype technologies that bake lunar simulants into bricks or melt them into landing pads using concentrated sunlight. These techniques would make it possible to build habitats, roads, and structures without launching heavy cargo from Earth. Over time, such innovations could lead to a fully self-sustaining lunar outpost, greatly reducing mission cost and complexity. Meanwhile, scientific research will be a constant focus. The moon is a treasure trove of untouched history. Its surface has preserved a near-pristine record of the solar system, with impact craters, volcanic plains, and polar ice that have remained unchanged for billions of years. Astronauts will gather samples, drill cores, and deploy instruments to study everything from lunar geology to cosmic radiation. They'll monitor how the human body adapts to low gravity and prolonged isolation, knowledge vital for future Mars missions. Medical experiments, autonomous health systems, and psychological studies will be tested under real-world conditions. Overhead, the Lunar Gateway will serve as a flexible support station in lunar orbit. Much smaller than the International Space Station, the Gateway will host short-duration crews and dock with visiting spacecraft, including Orion and commercial landers. It will provide communications relays, storage, and medical facilities. Crucially, it offers a staging point for missions to the surface or eventually deeper into space. Built with international collaboration, Gateway modules are already in development, powered by solar arrays and propelled by electric ion thrusters. Canada is contributing a robotic arm, Europe is delivering life support systems, and Japan will supply logistics modules. As a modular platform, Gateway can expand with new labs, crew quarters, or fuel depots over time, adapting to future needs and technologies. All these efforts, surface bases, rovers, habitats, orbiting platforms, are ultimately aimed at something bigger, preparing for the human journey to Mars. Mars is a vastly more distant and challenging world, with long travel times, deadly radiation, and a thin atmosphere. But every problem faced there has a mirror on the moon. Artemis allows NASA to test closed-loop life support systems, autonomous operations, and emergency procedures while remaining just 3 days from Earth. Learning how to store food for months, protect humans from cosmic rays, or communicate with long delays will directly inform future Mars missions. Even the way crews are selected and trained, balancing skills, adaptability, and mental resilience will be shaped by the lessons of Artemis. The Artemis program isn't just about engineering or science, it's also about diplomacy and ethics. Over 30 countries have now signed the Artemis Accords, a non-binding agreement that outlines peaceful principles for space exploration. These accords promote transparency, data sharing, responsible mining of lunar resources, and respect for historic sites like the Apollo landing areas. They also reaffirm that outer space belongs to all humankind, not to one nation or company. As more nations and private firms enter the space arena, the Artemis framework could help prevent future conflicts and foster cooperation in the most uncharted frontier we've ever faced. And so, step by step, what once seemed like science fiction becomes reality. In the years ahead, we may witness astronauts building habitats on the moon with machines that churn regolith into walls. We may see multinational crews riding across the dusty surface in futuristic rovers, conducting joint research or repairing solar panels. We might watch in real time as water is harvested from a sunless crater, or as the first Martian-bound spacecraft assembles in orbit above the moon. All of it will be built on the foundation laid by Artemis, and all of it reminds us that the moon is not the final destination, it is the launch pad for everything that follows. As the Artemis generation rises, students, engineers, dreamers, and explorers, the moon is no longer just a symbol of the past. It is a beacon for the future. The Artemis program is our bold step forward, not just to return to the moon, but to redefine what it means to explore, to live, and to thrive beyond Earth. It's a journey of science, of unity, and of hope. And for the first time in human history, it is one we are taking together.